Dear guests, my name is Agnieszka Gładysz, and together with my colleague Joanna Anczak, we are representing the Department of Strategy and Analysis in the Office of Electronic Communication. We have prepared a presentation concerning broadband mapping process in Poland. We plan to focus on the main principles of the broadband mapping process in Poland, legal framework, data usage, and then data collection methods. Why have we decided to start mapping telecom infrastructure? The first question worth addressing. The main reason was the very low broadband internet penetration rate in 2009. Next reason was the increase of telecom investments. Development of this sector was accelerated via EU co-financed initiatives. Furthermore, our objective was to eliminate investment barriers in the telco sector. And finally, to enable the acceleration of next-generation network deployment, we needed to assess the existing environment. In 2010, the Polish government enacted the Broadband Act, also known as Mega Act, which supports the development of telecommunication services and networks. It is the key act which started the inventory of telecom infrastructure in Poland. Article 29 of the Broadband Act provides a legal basis of drawing up the inventory of existing telecommunication infrastructure and public telecommunication networks within the territory of Poland. The execution order on the implementation details combined with Article 29 of the Broadband Act was issued in the Ordinance of January 2011. Both legal acts form a legal foundation for designing the broadband infrastructure information system. The second ordinance, dated February 2014, expanded the previous one, which is still in force. It describes in more detail the scope of inventory process. Article 29 of the Broadband Act outlines data collection methodology, backbone and distribution networks, telecommunication hubs, network links, buildings to enable collocation, entities that have reporting obligations concerning telecommunication infrastructure data to the President of UKE include local government authorities, public utility units, and telecommunications companies. According to the results of last inventories, in Poland we have approximately 5,300 telecom companies. In addition, 2,800 government units and almost 700 utility enterprises that own telecom infrastructure and are obliged to deliver the data during inventory. This means that our market is very diversified. Article 29 precisely states the frequency of data inventory collection, which is performed annually. The reporting deadline for telecommunication companies, local government units, and public utility enterprises is 21st of March. The reporting scope is based on data from the end of December of the previous calendar year. All entities are obliged to send reports according to the framework specified in the Broadband Infrastructure Information System. The general model implemented in the Broadband Infrastructure Information System is compatible with all regulations and consists of a backbone network, which is a top layer of public telecommunication network, aggregating traffic from the lower layers of the network. A distribution network, public telecommunication network layer, connecting the backbone nodes of the telecommunication network, which aggregates traffic from end users of telecommunication access network nodes. And finally, access network, which is the lowest layer of the public telecommunication network that links telecommunication traffic aggregation points of the telecommunication terminal equipment. And the point of aggregation might be an Ethernet switch, DSLAM, ONU, ONT, or base aggregate traffic from the terminals. Address supplied by access nodes represent the coverage of an access network. Nodes are connected by cable lines, either by fiber lines or by radio lines. Leased lines are represented by relative logical connectivity. Coverage of an access network is represented by addresses supplied by access nodes. UKE also collects data about radio nodes and radio lines. Gathered data concerns mostly localization and specified parameters of objects. This picture shows our radio model implemented in the Broadband Infrastructure Information System. As you can see, there is information about technical details like azimuth, angle width, or sector and radius.
I would also like to warmly welcome all. My name is Joanna Antczak and I'm representing the Data Geoprocessing Unit in Department of Strategy and Analysis. I will demonstrate you the broadband data collection system, and I will tell you about the databases, especially state databases, which we use in the department in the data collection process. So, you already know the legal basis for our data collection and what the data model is. So now I will tell you how we collect in. Data is collected in SIIS. It's a broadband infrastructure information system. The system provides two paths for data delivery. For small companies, delivering a maximum of several hundred records using web form, and also for large or medium-sized companies using files in CSV or XML formats. The web form allows enter a single data record. Large companies in general can create data packages consisting of multiple files, and during import, files are validated in terms of structural correctness and formal compliance. In the final stage, the correctness of data logic is also performed. As I mentioned, each of the records can be entered into the SIIS using the web form. The process of saving the form is proceeded by validation, checking whether all required files are filled, wherever the input data is in the correct form, etc. There is also autocomplete for localization data, as well as for files that links to other objects in the system. After entering the first few characters of the name, a limited list of possible matches appears. Now you will see a short demonstration of how SIIS works. After login, you can see homepage with general statistics. The first form is a form with data of the entity providing information, like addresses data, registration number, contact details. The second form is the form of collocation building, contain addresses data, type of building, and detailed technical information about the possibility of installing telecommunication infrastructure. The third form contains data about network node. There are warnings after logical verification data, hints on how to correct the data. The form contains address data, information of the possibility of sharing infrastructure, information on interfaces like technology, bandwidth, number of lines. The next form is a form of a cable line, fiber optic or copper. The line extends between the nodes are cable connection points marked as A and B. Statements is a special type of form. It's filled out by the user who hasn't telecommunication infrastructure or who ended procedure delivering data. Bigger companies import files. We can see stages of transfer and we have to wait. The import ended. Imported data can be exported in XML or CSV format. The data correctness report, we can see all logical warnings. It's also important to each operator can create accounts in the system for their employees. Then we can see system from perspective of our office. First page is a dashboard with information about number of login user, number of record, formal correctness, the data. Then we can see the list of entities. We choose the same entity as we used before. There we have all general information about the entity and number of records and type. We can see exactly the same information about import, export, data correctness and users. As you can see, only about 0.3% of data are provided by web forms. The remaining data are delivered by files. Only about 1% of the data are provided in XML format, the rest in CSV. Let's look at the second graph. Web forms for data and statements are used by over 70% of companies. This proves that web interface is also essential. At the beginning, a lot of entities had difficulties to prepare XML or CSV files. So it was very desirable to create some desktop application which would look and work similar to Excel, but also generates files which will be accepted in our system without errors. So we decided to create Excel-like tool, which has the same code for validate the data as main application. And this tool gives user confidence that files generated by it will be accepted without error in main system. We have made effort to create mini SIIS to be as much friendly as can be. So it has functions similar to Excel and generate good files as well. Here we have movie about how mini SIIS works. You can import CSV file, choose the file. The data was imported to applications. We have several tabs: entity data, service providers, collocation, own nodes, foreign nodes, node interfaces, radio access, cable connections, cable lines, wireless lines, node connections, end of points. There we have the largest amount of data, and services. Now, if we want to validate data, we click in this green arrow before validation. We have to save data to our local database, so we accept it and save the pointed database. Now we see validation progress. Checking end of points lasts the longest because this object is much more than others. Validation is done, and we can see that entity data is marked by the red circle as invalid. We can see which columns are incorrect, and then we correct data by choosing correct entity from autocomplete field and do validation once again. We are waiting for results once again. Application again has to check all data. And now everything is okay, and is marked by green circle. Now we want to check data correctness rules. We click on this icon and wait for complete of function. And again at the bottom right, you can see data correctness rules return some alerts. We can see which tabs reported alerts. These tabs are marked by yellow. It is nodes, wireless and also endpoints. In console we can see message or its alerts. After all, we export all of data to CSV file. These alerts from a data correctness rule will not block the import to main application, but main application also will return alerts, and user will have to correct this data anyway. Mini SIIS is not recommended to huge amount of data. It is rather for smaller entities. The biggest one needs some tool without GUI. So we created one more tool called NDDO. In Polish it's tool for big entities. It is a command line tool with functionality to validate data and check their correctness. It is dedicated to big entities, so it accepts only CSV files, because in practice these companies produce only CSV files. Now I will present how tool for big entities works. We run program to check this file, app runs validation without data correctness rules, and in this case it ends with success. Then we run apps with error parameter, which means that the data correctness rule will be checked, and this program returns some alerts, and it means that data is not complete correct. System allows also to export the data to XML and CSV files. Similar to import, export also is async function. This is because generating huge amount of data can last very long, and to assure continuous and reliable work of system, we decided to export data async and send email to user after file will be ready to download. Now I will tell you a little about the databases we use. The core database maintained by the Department of Strategy and Analysis of UKE is of course SIIS database. In addition to the SIIS system, we use different either public or commercial databases. The most important additional base is National Official Register of the Territorial Division of the country. This database is managed by Statistics Poland. It's a national statistical office. And this database provides us information about unique identifiers for cities, streets, etc. The next one is the PRG, Polish National Register of Boundaries, managed by the Head Office of Geodesy and Cartography. Thanks to this database, we have information about the geographical coordinates of all buildings, and we can also geocode our address data. The next one is Topographic Database, managed by Head Office of Geodesy and Cartography also. This database provides us with, among other things, information about categories of buildings, like multifamily building, family building, business building, etc. And the next one is Universal Electronic System for Registration of the Population. This database is managed by Ministry of the Interior and Administration, and it gives us information about the age structure in buildings. Moreover, Department of Strategy and Analysis uses commercial demographic databases which contain information on variable representing of population and commercial activity. Using these databases, we can create tailored indicators. Subject to analysis of our office is specially defined indicators such as demographic burden, proportion of people in a productive age to a post-productive age, and average income per household or building. This slide explains what kind of information about every type of building we have. All of the gathered data presented on the following slide comes from the linking of every existing databases used in our office.
For inventory purposes, we have created our own address database, which we use to verify data entered by telecommunication companies. Each address needs to be standardized and replenished with missing data. Following this action, we mark the duplicates and add special coordinates. Full address base is shared with stakeholders at the beginning of inventory so they can compare our base with their own. In addition to standardization, the address data obtained in the inventory process is geocoded. Operators, based on the reference address database provided annually by the Office of Electronic Communication, usually provide a complete set of address data, both the address points and coordinates. Nevertheless, address points without coordinates are reported. That is why our department also carries out the geocoding process. Using publicly available database, which was mentioned earlier by Joanna, we assign correct or approximate coordinates to addresses without coordinates. Below we have illustrated example diagrams showing how geocoding algorithms work. One of the most accurate methods is approximation of the missing coordinates between two coordinates. For example, 5 between 3 and 7. Another similar method, but more advanced, is the approximation of the missing coordinates between two coordinates. For example, 5 between 3 and 7, and additionally, processing information about the address coordinates on the other side of the street. We seldom use the street center method and statistical region method, as cannot obtain exact coordinates by implementing them. Nonetheless, we probably no longer have a situation where we lack the data coordinates of addresses for the entire street or town. To ensure the overall quality of the mapping, all data has to be verified. We have been taking care of the quality data for many years, which is why our system has been supplied with a number of data quality rules. You can see some examples on the slide. An invalid house number illustrates that the building address is not in the reference address database. The radius of the sector outside the indicated range shows that the radius value specified exceeds the accepted warning thresholds in the context of the maximum radius for that technology. We have observed practices where the backbone layer was indicated for the Wi-Fi interfaces. However, Wi-Fi is not a backbone network technology. The coordinates are misplaced outside the indicated district. Our data collected through the inventory are shared with our international partners, International Telecommunication Union and the European Commission. These organizations publish inventory data on their own map portals. Presented by the International Telecommunication Union, interactive terrestrial transmission maps are ICT data mapping platform that allows specifically to summarize the national backbone connectivity as well as other key indicators for the ICT sector. The aim of the European Broadband Mapping Portal is to provide more transparency concerning broadband services to end users. We also participated in an international exchange of our expertise, knowledge and experience. We took part in the tweeting project in Georgia. One of the most important topics for the Georgian regulator was broadband mapping. During our 15 expert working days, we attended many meetings with the Georgian regulator and representatives of telco operators. We developed the guidelines on how to implement the broadband mapping project in Georgia. Thanks to our vast experience in broadband mapping over the years, we have developed the Barrack Guidelines, which provide geographical surveys on network deployments. This is intended to provide guidelines to the national regulatory authorities on universal approaches to develop these geographical surveys. Two of our experts have specifically participated in the preparation of the following chapters: Geographical Spatial Resolution of Data and Data and Characterization of GIS System. And just at the end, I want to mention advantages of mapping infrastructure and services. First of all, it enables verification of objects, lines, nodes, for the purposes of sharing. It facilitates business decisions regarding investments. For example, possibility of finding areas where there is no market competition. Designation of areas for operational program Digital Poland. Also the possibility of identifying areas at risk of digital exclusion and barriers to the development of broadband services. And finally, also provides information for spatial planning. At the end of our presentation, I invite you for a short video where you can see what tools we use to map broadband infrastructure in Poland. Thank you for your attention, and I invite you for the next webinar series prepared by the Office of Electronic Communication. Thank you.
There are still areas in Poland where telecommunications infrastructure is lacking, or investments are duplicated. Without access to reliable data, operators cannot make business decisions. This is why consumers wait longer for modern services. What do entrepreneurs need? Information. Thanks to the single information point and search engine, the Office of Electronic Communications facilitates the obtaining of comprehensive data on the status and development prospects of the telecommunications sector. What is the single information point for? The single information point gathers data from many sources, including the databases of Statistics Poland, the Central Office of Geodesy and Cartography, and the Office of Electronic Communications. The system provides information on passive infrastructure and investments planned in telecommunications, transport and energy. Data for network operators, road managers, property managers, and local government representatives is available in one place and includes existing and planned technical infrastructure, technological channels, rates for occupying the road lane. The system supports the co-investment and cooperation of telecommunications companies, network operators from various industries, and local governments. What can we find in the UKE search engine? The search engine is an easy way to check what broadband services are available in Poland and which operators provide them. By entering the address and choosing filters, we get results regarding the location of telecommunications nodes, transmission systems, and buildings enabling co-location, the location of buildings with telecommunications network coverage, the type of technology used. The information is visualized on the map, while the data is available in the form of printouts and CSV, PDF, XLSX files. The search engine allows you to check the availability of services in a given place, as well as report the demand for additional services. Thanks to our portals, we remove access barriers to broadband internet.